white shirt પહેરવા જેવું તો નથી આમ તો. ઓકે, એનીવે આપણા બેકઅપ માટે છે એવું કે લાઈવ જતું નથી, રાઈટ? પ્રોબેબલી we just us. Okay, so let's start with circular motion. Let's first understand circular motion and then we'll look at gravitational fields and gravitational forces, right? So circular motion, see, whenever we study motion there are a few simple things that we need to understand. The first is displacement, right? The next is distance or length, meaning the distance traveled. So I will say displacement covers that. Then we have velocity, then we have acceleration, and once we have acceleration, so that is time, right? Time period and time, right? Once we have acceleration we can define force, and once we have the understanding of force then we can now shift to circular motion, है ना? Now let's say if this is a circle, right? So if you start from here, let's say this is your point A and you go to this point which is B, right? The distance traveled will be a part of the circle, right? If you are over here, the distance traveled will be a arc of circle, है ना? But the displacement is going to be the shortest distance between point A and B. Because this is circular motion, there will be an angular displacement. This angular displacement is denoted by letter theta, and we know that this can be measured best in radians, right? So we can, and we say that 360 degree is equal to 2 pi radians. So if I want to change degree to radian, what will I do? I will take that degree, x degree multiplied by pi, and then divide the whole thing by 180. It changes this to, and if I wanted to actually change this radian into degree, you take x radian, right, multiplied by 180 and then divide the whole thing by pi. As simple as that. Now what is velocity? Velocity is rate of change of displacement, right? So can I say for our circular motion displacement is theta, right? And for linear motion that displacement was denoted by s. We know that velocity is by ds by dt. Acceleration was d square s by dt or dv by dt, and force is nothing but mass into either of these two, and force is equal to m, right? Now let's develop what do we do the same for velocity. For velocity, see, if at let's say time t1 it's at a and at time t2 if it is at b, then the displacement is delta theta, and this is happening in a time delta t, right? So I will write this is delta theta by delta t. Okay. And this can be denoted by omega. For circular motion, velocity is omega, right? Now our entire study today is not only finding that what is it for circular motion, but also relating circular motion and linear motion. Now can I say that this delta theta is equal to, also what is 1 radian? If this is r, then okay, so if arc length is equal to radius, your angle is 1 radian, right? So theta or arc length L is written as r theta, है ना? So you can write arc length L as arc theta. So delta theta, can I write delta theta? So the length traveled is equal to r into delta theta. है ना, the length, है ना, and therefore can I say that over here velocity is nothing but delta L by delta t, है ना. Can I say that V is equal to R delta theta by delta t? Can I say V is equal to R into omega? So the relationship between the linear velocity and angular velocity is that angular velocity multiplied by R, right? What does this mean? This actually means for us that let's consider again a particle going in circular motion, right? Now if it travels from here to here, right, it might have an angular velocity of omega. If this is the center, then a particle traveling from here to here will also have an angular velocity of omega. But both of these will have different linear velocities, right? Both of them take the same time to reach a certain angle away, but they are also taking same time to reach different distances away, which means their velocities are different. So for a wheel that is rotating, its angular velocity is constant, but the linear velocity will depend on where are you checking the velocity of the wheel, right? So a wheel going at 1000 rpm, right, if it's a 16-inch wheel, will have a different distance traveled compared to a wheel which has 18 inches of diameter, right? Makes sense, है ना? Okay. Now if we know that, can we also agree that velocity is a vector quantity and that if direction changes, velocity also changes, right? Now let's say at this point A, the velocity is in this direction, which is let's say v1, right? At point B, the velocity is like this, which is v2. Now to make it easy, and because these are vectors, can I draw them like this, that this is v2? Their lengths are equal because the magnitude is still same. Can I say this is nothing but delta v? And can I also say that this angle has to be delta theta? है ना? These will be similar triangles. The triangles made here and the triangle made here, right? If I make it like this, these two triangles are going to be similar, but not going into it, just that this angle will also be delta theta. Angle is delta theta. So can I say acceleration is nothing but delta v by delta theta, है ना? This is obvious, right? But how do we find out angular acceleration, right? To understand that, look at page number. We are so far away actually. Come to page 335, right? Now if this was a circular path, right, I am going to derive using this. You don't actually need a textbook, right? If this is the angle that you are looking at, can I say that delta v into v is equal to v is equal to delta theta into delta v, right? Angular displacement, again delta v is equal to theta into v, angular displacement into the length is equal to the arc, है ना, arc length, right? So that is, है ना? Now what you simply do is divide both the sides, right? Divide both the sides by delta t. Okay, what you will find, we already know that this is acceleration, so acceleration is equal to omega into v, है ना? Acceleration is equal to omega into v. Now if we further expand this, acceleration is equal to omega into v, and we know that v is equal to omega into r, right? So if I subtend that, then omega square into r is acceleration. That is the first thing. Then if instead of, so this is one equation number 2, let's say this is our equation number 1, and if this is substituted over here, we get this equation. But I can also write omega is equal to v by r. In that case, a is equal to v square upon r. This is your third equation. So depending on what values are given, you can find out this acceleration. Now this also brings us to a very important logic, that because acceleration exists, there must be forces, right? Because F is equal to ma, right? Newton's first law of motion cannot change without, yes, because of inertia, motion cannot change without any external forces, right? And we have seen that the velocity is changing. If velocity is changing, then for sure there is some force, right? And that force finds its existence through this equation, all the three equations for that matter, है ना, कि ये force exist तो करता है. Now if we want to talk about this force, we must first understand that how does this force act, है ना, the force that keeps. So have you ever played with something, made it go round and round, है ना? Your charger, a stone, a lot of things, right? Roller coaster is an example which keeps the train in the loop, right? So these forces are acting over there. So the force required to keep any object in the loop is centripetal force, right? Let's understand it like this. You've all, I believe, played with a toy that you can roll like this, है ना? Now if let's say it's going in this direction, right, and you're holding it from here, if this thread breaks from here, what direction will this toy go in? So it will go like this, I believe. It will not keep on going in circular motion. From this example, can you understand that the circular motion was because of this string? The string was continuously pulling this toy, है ना? So this centripetal motion is towards the center. The string is pulling it towards the center, right? Now if you look at the circular motion like this, at any given point the force is towards the center, right? And this is how that object wants to go out. What will happen? It will reach over here. It will reach over here as a resultant, है ना? Now at a certain point, let's say this point, again the force is towards the center, but this wants to go out tangentially, so again the resultant brings it over here. This keeps on happening at each and every point of the circular path, which is why circular motion. This will continue to exhibit a circular motion. Huh. So whenever, let's say that, let's talk about satellite, because we are going to understand gravitation as the next part of this topic, right? So if you think about satellite, right, that satellite is going so fast, okay, that it wants to go out of this circular motion, but the gravitational pull pulls it over here. દેવાંશી રેકોર્ડ થાય છે, આખું બીજી વાર જોઈને આખી બીજી વાર નોટ્સ બનાવજો, અત્યારે ધ્યાનથી સાંભળો, right? Now this wants to go so fast, right, and escape the circular motion, right, because velocity is linear, it is straightforward, but the gravitation is pulling it towards the center, right? The faster it goes, the greater radius it will have of motion, right? Because these are two vectors. So one vector is like this, the other vector is like this. If this is larger, this is your resultant. If this is larger, this will be your resultant, right? So the radius is also in a balance. The radius of the circular motion also comes out from the effect of these two forces, which we will see. है ना? All of our questions of board depend a lot on this balance. है ना? But wherever it is rotating, these two forces are somehow balanced. है ना? In such a way that it does not go out, but it does not even come in. So now if you think of a satellite, it does want to fall on the earth, right? So this is the earth and this is the satellite. It is traveling like this, but it does want to fall on the earth. By the time it reaches to a point where it should be nearer to earth, there is no more earth to fall. The position of earth has shifted for it. And the gravitational pull is towards the center of the earth. So when, let's look at it like this, right? When at this point it was falling, right? It was falling in this direction.
Yeah, I want to follow that.
Right? But resultant took it here.
Correct.
Now when it reaches here, the force is not like this. The force is like this.
Yeah.
And the other force is like this. So again resultant brings it here. This keeps on happening over and over and over again. So the satellite stays in circular motion. Make sense? Okay. Now, the origins of centripetal force, I think you can easily understand a lot of other examples that the book has discussed. I'll not go into examples. One small topic, calculating orbital speed of the satellite. Yes.
So, in the same example, does it mean that the tension in the string is equal to the centripetal force acting on the string?
Yes, yes. It should. But what will change? Weight will change. Let's say the string is rotated like this, right? So when it reaches over here, the force is also towards the center and its weight is also towards the center. But when it is over here, the weight is downwards, away from the center, but the force is still towards the center, right? So in a string on earth, there are a lot of equilibrium of forces or a lot of forces on the free body diagram that we draw, but if it was horizontal, then yes, the only force that is pulling it towards inside is the centripetal force, tension is equal to that. Now they have simply said that mv square upon r, or mr omega square, should be equal to ma for a satellite, or rather, because the satellite g, now if you know the value of g, right, these m values will be cancelled out. If I know that I want to keep a satellite at a certain radius, I will be able to find out at what velocity should it be set to, such that it keeps on going in that orbit. Because what do we do right now is we decide a orbit, right? And we will place that satellite with a certain speed over there, and then we will leave it. You don't need to have a satellite with a continuous fuel supply that it keeps on rotating. You just keep it there, and then it will keep on going over and over and over again, due to the balance of these two forces. Makes sense? Yeah. And on that we have two satellites, geostationary and communication satellite. Geostationary satellite is exactly on the top of a certain place, and therefore that satellite will have a time period equal to the time period of earth. Yeah. Once you know the time period, you can find out its angular velocity. Omega is equal to 2 pi by t. Once you know the omega, you can place the omega over here. Yeah. So that we will see in the gravitation part, but it's just understandable, right? Let us then move to the next part of the discussion, which is gravitation. So what is gravitational force?
Gravitational force, it is a force that is directly proportional to the power of the masses and inversely proportional to the separation.
Okay, it is a force experienced by everything that has mass, yeah, right? So gravitational force is equal to gm1 m2 upon r square, where r is the distance between the two objects, है ना? We can consider, ये question they are asking this question repeatedly, बहुत बार पूछा है, that how can you consider these to be point masses, these masses to be point masses, stars दिया है, planet दिया है, but they will ask you how can you consider that these objects are point masses? What will you write? Because the center of gravity is at the point. No. Okay, we'll come back to this question right now. This equation was derived considering that these two are point masses, because if masses are distributed, their inertia is also distributed, right? Which creates problem in classic physics or equations like this. Now, to answer that question, that why can we consider these to be point masses? Because the distance between the two masses is much greater than their sizes, right? The size of Earth is 6400 kilometer is the radius, right? I believe Sun is 100 times larger at least than the planet, but the distance between Sun and Earth is even larger than the combined size of both Sun and Earth. So when we try to find out the gravitational force between Sun and Earth using this equation, we can consider them to be point masses. So if the size of the two masses is larger than the distance, then this equation will not be true. No. But that does not happen. We will see in this chapter only why gravitation is the weakest force. Okay? Now, let us start with F is equal to G m1 m2 upon r square. And let's first find out that if this is the force, then what is this equation doing? Why do we study this equation till now if this equation is true, where G is the gravitational constant whose value is 6.6?
This is related to other masses, like two masses that each have a.
So what? So what? This is also a force, m into a. This is Newton's second law of motion.
Yeah.
That is Newton's law of gravitation.
That is related to one gravitational force. That's the circle of one planet.
Okay, I am on Earth. Why can't I use that equation?
Because that is comparing the force between Earth and say some other point.
No, it's I can use both the equation to find out what should be my weight on Earth. है ना? Second equation. See, Newton's third law of motion. The force of attraction should be equal and opposite. If Earth is pulling me with 100 newtons of force, which is my weight, I am also pulling Earth with 100 newton of force. है ना? Equal and opposite. Why Earth doesn't move? Because the inertia of Earth is so huge that only I will move. Right? That solves that question, that what is inertia and why only I move. But both me and Earth are attracting each other equally and opposite. So what is going on with these two equations? Why are there two equations? Can I use this equation to find out my weight on Earth?
Yes.
Should I be able to? Okay, let's say m1 is my mass, m2 is the mass of Earth.
Then you cannot consider it to be point mass because the ratio between your distance and the Earth's distance will be much greater than the relative distance.
Okay, that is one point why we don't consider that. And one more thing.
Gravitation constant.
That is still there. The next point is that this equation works when the distances are too large. As he said, that I cannot consider these two masses as the point mass because Earth is much bigger than I am, and I'm standing on Earth. So the distance is not that huge. In fact, the distance is equal to the size of Earth. So they are not point masses. But also, this equation works only when the distance is in a very small range near the surface of the Earth. If it is Sun, if it is Moon, then this equation does not hold true anymore.
That is only for the surface.
Yes. So why doesn't it hold true? To understand that, let us understand this is Earth. Right? Now, if the distance is very small, right? what can I do? I can just find out the work done to move from one place to another and say that that is increase in potential energy, and from there work done is equal to force into distance. I can find out the force is m into g, right? In that case I was able to do that. Here what will happen if I go much further away from earth, right, such that this radius has increased drastically, we know that the fields of gravitation gets weaker and weaker and weaker as we go away from the planet or from the body that is exerting this force. So this field will get weaker and the value of g will not be 9.8 anymore. If let's say I go near to the center of the earth, this much part of the earth is not pulling me anymore. So again the value of G does not remain 9.8, right? So this is the equation derived from the law of conservation of energy. This is an equation which is derived from the logic of relationship of gravitation between two masses. So this is always true, and this is true for distances which are much smaller than the radius of the earth, right? With that in mind, should I be now, if these two equations are equal, should I be able to equate them? Yeah, right? And let's say this m1 is my mass, m2 is the mass of the earth. If m1 and m1 can get cancelled, can I find the value of g at a given distance? है ना? If the distance changes, the value of g changes. What I was discussing just in the last page. This is what I was discussing. Right? The radius is 6400 kilometer. Right? The height of Mount Everest above the sea level is 8 kilometer. I think. Yeah, 8,000 meters. 8100 each. Okay, 8,000 kilometer. That is the highest above the earth we can go. Now this 8 kilometer is just a very small part of this 6400. Think of anything else. You're always in a very small range, even less than 1%. So the variation in the value of G 9.81 plus or minus 1%. है ना? And we've understood in our paper 5 that this 1% is within the scope of experimental accuracy. है ना? So I can say that 9.81 is a correct value, but only for very small range of distances. है ना? Otherwise, this will change.
So this definition is only true if the distance between the two.
Right? Now, we also should remember that gravitational forces or gravitational field is always attractive. है ना? Let's go back to this planet, right? The gravitational field is, okay, let's make a new planet, right? This is a planet, right? Spherical. The gravitational field is always to the center of the planet, है ना? So it is radial. As you go away from the planet, as the field lines, this is true for any field line, as the number of field line decrease, the strength of the field is also decreasing, है ना? So right now it's radial, but if you're standing on the surface of earth, all the gravitational field lines are parallel to each other. For you, they are perpendicular to the ground, and they are equidistant. So on the earth, again reiterating from what we have seen, gm upon r square is equal to the gravitational acceleration. Why is it constant? Because the gravitational field is also constant on the surface of earth. If it is constant, the gravitational field lines are equidistant and they must be parallel to each other. Right? In a simple manner, understand it like this: if I zoom enough into this area, eventually I will reach where it feels like this line is parallel to this surface, for us to understand it. Almost parallel. Yes, because the distance is so huge, it will be parallel at this point, right? So on the surfaces of the heavenly bodies, right, the size, the gravitational field lines are parallel, but away they are radial, such that the field strength goes on decreasing. right?
Does that mean that on a surface such as mountains, the gravitational field will be
No. Even if it is a mountain, its difference in height compared to the size of Earth is going to be negligible, right? And also from here we can also understand that this law of gravitation is useless and is very weak for objects like humans, cars and buildings. Okay, let's think of a car, right? I think a truck will weigh, empty truck might weigh around 3500 kilogram, है ना? Let's an empty truck weighs 3500 kilogram. This is the weight of that, है ना? Okay, let's go with mass only, right? My mass is 100 kilogram. Find out what is the force of gravitation. F is equal to G m1 m2 upon r square, and we are standing 1 meter apart. Okay, now even without any calculation, just simply look at this. This value of r is 6400 into 10 to the power 3. Value of g is whatever into 10 to the power minus 11, that is 3.5 into 10 to the power 5. Shall I write 5? Two zeros over here and three zeros of this. Huh?
okay.
And square of this. Acha, distance. Sorry. It's just 1 meter. है ना? है ना? What is the magnitude of this force? In the order of 10 to the power minus 6 Newton. है ना?
Yeah.
So the force of gravitation is only considerable for bodies that are as huge as planets,
Yeah.
stars, natural satellites. For much smaller bodies that we see, it is negligible, which is why if I take a magnet, a metal can get pulled towards magnet, overcoming gravitational field, है ना? So out of gravitational, electric and magnetic, gravitational is the weakest. Does this make sense over here? Are you all sure? Now let us understand about gravitational potential, right? Let's say there is a planet over here. Okay, now what should be done to take a body away from this planet? Work should be done against gravity. I'm sorry if I did not frame that question properly. What can you do if you want to take it away? You need to apply some force, and if you are applying a force through distance, that is work done, right? So what you are doing, you are storing some energy, है ना? Work, because of energy cannot be created, cannot be destroyed statement. What is happening to work? Work is nothing but energy, and that energy is getting stored in this object, right? And we also know that if there is a planet and let's say there is an object going from so far away that it does not come under gravitational field of this planet, it will not move towards this planet, right? But if it does, what energy will it lose? Potential. It will lose gravitational potential energy, its kinetic energy will increase, right? Now what is its gravitational potential at infinity? What? Zero. Potential infinity. But why? Because you're doing work against, you're working against gravity. So I understand that you're working. I'm saying okay, zero. I accept that is the correct answer. I'm asking why should gravitational potential at infinity, at such a point where there is no gravitation, should be zero? Because it gets negative. Because there is no gravitation. अच्छा, है ना? Right? So the gravitation potential should be zero. As and when you come towards this object which is exerting this gravitation, right, the gravitational potential decreases, Why I am saying decreases? Because we have just understood that you need to apply something to again raise it to that value of 0. So the gravitation potential that we will see is always negative, right? The gravitational potential is always negative. So the space time is bent something like this. This is an object with gravity, है ना? It's like a valley, है ना? Something that comes over here is bound to fall inside, है ना? Its potential at this point is 0. Everywhere else it's negative. Does this make sense? Sure. Okay. Now let's look at our textbook. Right? They are discussing about this gravitational potential, energy in a gravitational field, and gravitational potential. Right? On page number 352. Right? On 352 and 353. Now they have said that gravitational potential, right, is equal to minus gm upon r. है ना? We've not been given a lot of explanation, and I think that is not necessary for us right now to understand this derivation, right? Equation we have to, not the derivation. And what is definition? Gravitational potential at a point is work done per unit mass in bringing a point mass from infinity to that point, right? And hence, what should be your change in gravitation, or what should be your gravitational potential energy? So this simply multiplied by mass, है the mass that is moved, है Therefore, this should be your gravitational potential energy. Make sense? Yeah. Here, it should also make sense that delta phi should be equal to minus gm upon 1 by r1 minus 1 by r2. Actually should have been r2 minus r1. ये minus थोड़ा common बन जाएगा तो ये flip हो जाएगा, है ना? Hello. And then you can also write the change in gravitational potential energy should be minus gmm upon 1 by r1 minus 1 by r2. Does this make sense? ऐसे होता है, right? Now they are giving some explanation. एक second, gravitational potential energy. No, it's very similar to what we have understood. ठीक है? Now, can we now equate this new equation that gmm upon r square is equal to mv square by r? Yeah. है ना? So for a satellite, let's say this is the surface of Earth and this is the satellite, right? So what is r? R is not the radius of Earth. Earth is the separation, है ना? So everywhere r is r plus h. H is the height above the surface and r is the radius. And a lot of times this mistake happens that you find out small r and forget to find the h, है ना? ठीक है. Going from here, can I write, and cancelling this m, can I write gm by r is equal to v square for that satellite? Yeah. And we know that v is equal to omega r, yeah, है ना? V square is equal to omega square r square, and omega is equal to 2 pi by t, है ना? If we have already not done this, I think we have not. So what should be omega? Omega, if it is velocity, then the total time to go in a full circle, right, divided, I mean 2 pi is the total angle and t is the time period, right? So if I substitute, can I write v square is equal to 4 pi square t square into r square? So can I write gm upon r is equal to 4 pi square r square upon t square? And if you know the time period, I want a geostationary satellite, the time period should be 24 hours, right? So this is known, this is a constant, this is a constant, this is a constant, this is a constant. You can find out the value of r, right? You know precisely where to keep this satellite, and from this equation you also know what velocity should it have, such that it will keep on being in that particular geostationary location. Makes sense? And if you extend this equation, right, let's look at this equation. So I can write gm upon r cube is equal to 4 pi square t square, right? I can invert this, or I can write t square is equal to 4 pi square upon gm into r cube. This is Kepler's law that t square is directly proportional to r cube for any planet in the solar system, or for that matter any heavenly body that is going around another in the universe. Okay, does this make sense? ठीक है. अब if this is a planet, right, and this is a satellite like moon going around, or if this is sun and this is a planet going around this. हाँ. अरे इधर ही था ये. अरे ये लो, वहां से स्टार्ट करना पड़ेगा. once more try. हाँ, चलो बैठ जाओ. थोड़ा टेम्परेचर, थोड़ा ह्यूमन टेम्परेचर कर दो ना. तुम तो जैकेट पहन के आए हो भाई. बैठ जाओ, चलो कोई बात कर लेंगे. Okay, coming back to this. Now if this is away, right, we know that potential energy decreases, right? What happens to the kinetic energy? So potential is zero, it is at the greatest, let's say over here. What is kinetic energy? Kinetic energy should be least, है ना? Right, when it comes here it is nearer, so potential is lower, it is in negative value, so the kinetic energy will be greater, है ना? What does this help in? This basically helps in that the angle subtended over here, right, let's say in time t the planet went, and this is center mein sun, and the planet went from here to here in time t. Over here what will happen? It will go this small arc in the same time t, right? So the average velocity around this planet, around this star for the planet remains constant. Average velocity वही रहेगा, and that is what we can consider because it has an average velocity, and this is not very elliptical path. We can consider कि Earth sun के आजू बाजू में जो जाता है वो circular है. Actually circular नहीं है, actually elliptical है, right? But ये circular ऐसे assume कर सकते हैं. Okay? This is why. What?
Velocity between two equal distances can be different.
Not two equal distances, different distances. This is a greater distance and this is a smaller distance.
But the average velocity is similar, right? No, but if both of these distances are equal. So
This distance is greater than this distance.
No, but if the distances are equal, then what effect would that have on the velocity?
So the velocity is not changing. It would mean that the velocity is not changing. But then that would break our logic of law of conservation of energy. Then we need to think something else, that why is this happening? But because we know this is happening and we observed it here as well, so it concretes our belief that this is happening and also explains why is it happening. Chalo guys, is any, just let me have a look in the textbook कि मैं कुछ भूल तो नहीं रहा हूँ, right? कनिश भी नहीं है. Okay, यहाँ पे टेक्स्ट बुक में they have also found out that what is the value of, if you want this time period to be 24 hours, what is the value of radius? right, for geostationary satellites. Every country that has a space program like India, Russia, China, है ना, US, all of them will have satellites at this radius only. And this radius or this region is known as Clark Belt. Clark Belt. Not, I don't think they'll ask you this directly, but Clark Belt is the, ठीक है. Now we will take just 2 minute का break. Then I have some questions. We will solve those questions, है ना. Yeah, yeah. હું બી એટલે બ્રેક લઉં છું. Okay, let's start. देखो, let's look at few questions. मैं year number भी बोलूँगा, so you can also open these questions, है ना. The first question is question 1 of 970 to MJ 2016, right? Question 1 from here. The question is, a binary star system consists of star A and B that orbit one another as illustrated in figure 1.1. Star A has a mass ma, right? It's like this, that this is a star A, this is a star B. Let's say this is ma, this is mb. The distance between the centers of these stars is 2.8 into 10 to the power 8 kilometer, right? And the center of rotation is at a distance d, right? Then they have said Star stars are in circular orbits with center of both the orbits at point P, a distance d from the center of star A. Explain why centripetal force acting on both stars is of same magnitude, because Newton's third law of motion states that action and reaction are equal and opposite. The force exerted by star A on star B should be equal and opposite to the force exerted by star B on star A. The period of the orbit of the stars is about point P is 4 years. Calculate the angular speed omega of the star. So omega we know is equal to 2 pi by T, right? And if you look at your answer, they have already told you to find this in radians per second. So 2 pi upon what is the period? The period is 4 years. So 4 years into 365 days into 24 hours into 60 minutes into 60 seconds. So this will give you the angular velocity, right? Once you have this angular velocity, they've asked you a next question. The next question says, should I erase this part? I believe. Yeah. The next question it says, कि the separation of centers of the star is 2.8 into 10 to the power 8 kilometer. The mass of the star A is ma, mass of star B is mb. The ratio ma upon mb is 3, right? Determine the distance d. Now what can you do here, guys? You can say, because in the first part of this question you just stated that the forces are equal and opposite, so you can say mr omega square or ma ra omega a square is equal to mb rb omega square will get cancelled. You have ma upon mb is equal to 3, right? So you can write ra upon, or rather 3 is equal to rb upon ra. Now what is rb? Rb is 2.8 into 10 to the power 8 kilometer, right? So I will write this as 10 to the power 11 meter. I'll have to take this in meter. The SI unit is meter, है ना? Minus d, and this much is d. So what can I write? This is RB, this is RA. So I'll equate it like this: 2.8 into 10 to the power 11 minus d whole square divided by d square is equal to 3. Right? From here you can easily find out the value of d. I'm leaving it to you. I don't have a calculator right now. So I think from here d can be found out. Then there is one more question. They are saying that use your answers in A2 and B1 to determine the mass mb of the star. Explain your working. Now, how can you find this? Can anyone help me over here? We know the distance of B, and we also know the we know that this is equal to 2.8 into 10 to the power 8 minus, or 10 to the power. So we can equate mr omega square and gmm by r. gmm, that is the force. So gmamb upon the distance between these two should be equal to mr omega square, right? And here this will be ma, or rather mb, है ना? But if I wanted to, so I can write ma is equal to 3 types of mb, है ना? So you need the value omega square, and you need so this is part ai and this is part a double I, right? I think MB and MB will get cancelled and you'll have to then find MA and then MB, or rather what you can do is over here, right, you can write GMA MB upon R square is equal to MAR omega square. Here MA will get cancelled and you will directly be able to find MB. है ना? If you forget one substitution, you will lose that 1 mark of finding MB. But if you go this way, right, the aim is not to take the force on MB, the aim is to find the value of MB. So you can take force on MA as well. Right? Then there is one more question we have. The question is from 970241ON21. Right? It says, with reference to velocity and acceleration, describe uniform circular motion. So 4. Right? With reference to velocity and acceleration, what is uniform circular motion? When a body stays in a certain radius at a constant magnitude of velocity is known as circular, and a constant centripetal acceleration as well. If the acceleration changes, the radius of rotation also changes. Then they have said, if you can find out diagram, right? Phone में open कर ही सके थे. अरे blindly थोड़ी खबर पड़ सकता bro. Okay. Two cars are moving around a horizontal circular track. One car follows path X and the other follows path Y as shown in figure 1.1. ठीक है, 1.1 सबको मिला है मित्रों? पाछे देतो अच्छा, okay, चलो. The radius of path X is 318 meter, path Y parallel to and 27 meter outside X. Both cars have mass 790. The maximum sideways friction force that the car can experience without sliding is same for both cars. The maximum speed at which car on path X, which is the inside path, can move around the track without sliding is 94 meters per second. So, can I say the sliding force F should be at this point equal to the centripetal force produced by the steering of the car? Or rather, you can equate it like this, that the force F is keeping it in circle, but its mr omega square value is pulling it out because it is moving with a velocity. The friction is one which is keeping it in the circle. So in either way you are going to equate these two forces, but logically this is taking it in, this is taking it out.
So can we use V is equal to omega OR?
Yes, we definitely can. M V square by R. You will find the value of it. Okay. M is given, V square is known, R is known. Then we have both car move around the track. Each car has the maximum speed at which it can move without sliding. Complete table 1.1, placing a tick in each row to indicate how the quantities indicate for the car. तो लेफ्ट हैंड साइड देखेंगे सेंट्रीपेटल एक्सेलरेशन. Y has a centripetal acceleration less than x, same or larger. If the mass is equal, है ना, but the radius is greater, so velocity will be smaller, है ना. For the same pull, what will happen? Therefore, the velocity. But here what will happen? If the force F is fixed, right? We know F is equal to m v square by r, right? If m is constant, F is constant. For both the cars, F is constant. So if r increases, what will happen to v?
V will increase.
Without sliding. Yes, theoretically speed will go on increasing. I am saying that अगर ये slide होने वाला force दोनों का same है, and the car at x, पीछे देखो कि car at x is already going at a maximum velocity, तो if car Y also goes at the same velocity,
तो
right?
कार को क्या होगा like
Right.
that point direct
But for both of these cars, if you now still take it simply, centripetal acceleration कैसा होना चाहिए दोनों cars का? Equal होना चाहिए, अलग होना चाहिए. See, centripetal acceleration can also be written like this: omega square r omega square. So if both of them, ठीक है. So y has greater than x. Maximum speed,
yeah
maximum speed किसका ज्यादा होगा? x का ही ज्यादा होगा, because both of them है ना. So x has y less than x. Time taken for one lap of the track if it has lesser velocity, है ना. If y का velocity कम है और उसका distance ज्यादा cover करना है ना. Right? So that is your answer. Is this understandable, guys? Then we have 9702 पे 42ON21. इसमें what is meant? Okay. What is meant by centripetal acceleration? I think ये तो तुम लोग आंसर कर सकते हो, है ना. An unpowered toy car moves freely along a smooth track that is initially horizontal. The track contains a vertical circular loop around which the car travels as shown in figure 1.1. Mass of car is 230 gram. Diameter of the loop is 62 centimeter. Do all of you have the question now?
it's loading
Okay. Assume that the resistive force acting on the car are negligible. State what happens to the magnitude of centripetal acceleration of the car as it moves around the loop from x to y. See, I think you were not there, but Shaurya had asked this question. So at x, the weight is here, है ना? But at y, the weight is also here and the centripetal acceleration is also here. So it increases. Increases. From x to y पूछो जो y to x मध्ये पूछो. Here centripetal towards the center. The force that is towards the center is increasing. Mg is now force which is also towards the center.
Oh, that is
Explain if the car remains in contact with the track. Explain if the car remains in contact with the track why the centripetal acceleration of the car at point y must be greater than 9.8 for it to remain in contact. Why should that happen? Because its weight is already downwards. For the car to stick to the track, the outward centripetal acceleration should be greater than the gravitational pull. है ना? The initial speed at which car B moves along the track is 3.8 meters per second. Determine whether the car is in contact with the track at point Y. Show your working. How will you do this? So you will first find out mv square by r. ये कितना है ना? So basically m, what is the mass? 230. 0.230 multiplied by velocity 3.8 meters per second. And what is the radius? The radius was in centimeter, 62. Diameter is 62, so 0.31 meter. Find out what is the value of this thing. If this is greater than 9.8, it sticks. If it is not, it does not.
so that's it for the question
All right. Huh? What is it? 10.7. So it would suggest with a reason, without calculation, whether your conclusion would be different for a mass of car of 460 gram or not. Will it be true or not? Same initial speed, है ना? देखो, actually you can just take v square by r. ये v square by r का वैल्यू क्या आ रहा है? इतना बताओ.
acceleration of formula
Right? Centripetal acceleration greater than 9.8, it will stick.
yeah so
Right? So instead of taking mass over here, just simply find out इसका value क्या है.
46.5
46.5, and here we have not considered mass. So this velocity is true for any mass because the centripetal acceleration is greater than 9.8. So this is true for any mass. You know, we have not considered mass at all. These are the three questions that were given to me by Yashvi. उसके डाउट्स थे, हमने सॉल्व किए. मैं यहाँ पे एंड कर रहा हूँ. नेक्स्ट क्लास से फिर से मैं बता दूंगा कि क्या टॉपिक होने वाला है. You can prepare your doubts, send them to me in advance. I will see if I should be solving them here or in the general doubt session. ठीक है? If that's it, bye bye.